And we are gaining momentum together with NIX guru of data science, Vitalii Tsymbaliuk, who will explain the algorithm and benefits of transferring the ML model. Vitalii, do you hear us?
Yes, I do. Hello.
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 It is nice to see you. How are you doing?
Excellent.
Great. And before we jump into your nice lecture, let's remind our viewers who just newly joined. So if you have any questions to our speakers or to ourselves, please use Telegram, both that you can see on our website, on our Telegram channel, on YouTube, or just simply drop a message on YouTube and we will answer. So, Vitalii, the floor is yours.
Yeah, that's good. Okay, let's start. So, hello, I'm Vitalii Tsymbaliuk, as the studio said, and I would like to share with you my presentation about once another serving method that we used in one of our projects. So first of all, let me introduce myself. I am an IT engineer since 2001, and it's about my commercial experience. And most of the time I worked as a Java developer or Java team lead. I even took a part in one of Sing Java event as a speaker. And as for data science, I'm working with machine learning and keen on ways to move machine learning models to production. This is my actually second speech at NIX MultiConf. Previous time on the NIX MultiConf number 4, there was a data science, but starting from this conference, we moved into something bigger, that is sync data. So as for this lecture content, during this lecture, we will investigate new machine learning serving solutions that we tried in our life, and we will implement both training and serving functionality. We will do metrics comparison of that models on both Python and Java side, and also we will collect the problems that we might see during this transformation and the ways out to solve the problems. So every new data science project always has something new, some new features that you never worked before, that you should start solving in this particular project. So we've got a new project that works with online ads platform. The idea was to buy an ads in mobile application and to show you some ads that is most likely interested for you, and the profit is on viewing the ads or clicking the ad or opening the ad or even buying some product that is on the ad. And one of the most important requirements for that platform is a speed. You should decide what to show you, and is it necessary to show you anything, like to pay for that bit or not, in very fast time, during the auction time. And the requirements is to do a machine learning request during the 50 milliseconds. So that's it. Definitely, as a very first step, we start with the data. We selected most valuable feature for us. We did a feature engineering. Our task was, in that particular project, our task was a binary classification on a very disbalanced data set. You know that majority of the ads don't returns any profits. So that was our data, and we tried different algorithms to solve our task. You might know that similar tasks on Kaggle competitions are mostly solved by some gradient boosting algorithms, and that's why we selected gradient boosting trees as well. Here are three of them that we paid our attention most: Scikit-learn, XGBoost, and LightGBM. So the very first is Scikit-learn with its new his gradient boosting. Very good algorithm, very promising. But there is a limitation with categorical data. Categorical data with high cardinality cannot be processed by this algorithm. And it was a showstopper for us. We can solve that, but reducing the cardinality, adding some implementation, but that always moves to loss in accuracy and adding some complexity with data preprocessing. So we move to XGBoost. XGBoost is another Kaggle winner. It's very fast, and what is good that it has currently experimental, but it has a categorical data support. However, another problem there that's again with cardinality. The documentation said that it can be worked around by reducing the cardinality, but with implementing something like one hot with low cardinality. And as for big cardinality, it's said that they are trying to implement same functionality like in LightGBM. It's about Fisher's partitioning methods. And while it's still experimental feature in XGBoost, we moved directly to LightGBM. LightGBM is again a Kaggle winner, so very good, very fast. And what is good about this this method that the categorical data is completely supported. It's fast. Training is really fast, and the accuracy of this algorithm is also good. We verified it with our data, and it serves all what we need from this algorithm. So moving directly to the main topic of this presentation is serving. We tried to find some good platform that worked for us. Like TensorFlow serving is good, but unfortunately it works with TensorFlow only and does not work with LightGBM. We tried to find some other MLOps tool that works for us, like serving LightGBM model. But unfortunately, we failed. So the question to the listeners: if you know anything that works good with LightGBM throughout the world of MLOps, please send it for us. We'll be glad to hear anything about that from your experience. So as we failed with MLOps tool, we moved to native supports of LGBM from the official documentation. It can be exported as a library and included into some functionality. But the problem is that looks like such model is platform dependent. So we cannot use platform dependent solution in our production environment. Another ways to work for us was to export our trained model to some format that can be imported on Java side, like and work there. we looked at NIX, which is Open Neural Network Exchange, and also we looked at PMML, that is a predictive model markup language. The very first of which is famous, it's known, we already worked with it, we transferred our neural networks with that format. It has a big community, good and actually good ways to transfer your model. But mainly it works with neural network. And the second one is less known, but still promising. And what is good, it works with LightGBM very good. It works with GBM models, like 3 models and so on. And that what is more interesting about that, it's very simple to implement on both Python and Java side, and we try to use that solution with our certain functionality requirement. So what is PMML? PMML is a format that was created in 2009 in a data mining group. And the most recent version of this format is 4.4.1. What is good is that format is easy to implement. It's XML-like format. It has libraries on every language that we used in our life, and even more, the library that we found supports lots of different models, not only LightGBM. We can use Scikit-learn models, we can use XGBoost and so on. And even more good about that is that the libraries that we found supports steps like preprocessing the data that can be integrated in the model. So these 2 libraries that we found, one of open scaling library and another is Nioka. We tried both these libraries in our case, and the open scaling one that we tried is actually simple to implement. It has 2 ways to export your model. You can export your model like LightGBM booster, like internal LGBM format, and then convert it to PMML. And another way is to integrate your LGBM into Scikit-learn pipeline and export that pipeline directly to PMML. And what is more good about this library is that it has a Java libraries as well, and you can use the same library to import your PMML on Java side and work with that there. And the documentation said that the transferred model to Java may be 5 to 15 times faster than the original version of your model. Actually, this doc is from the open scaling side. As for Nioka library, it has even bigger number of supported models. It is even simpler ways to export this model. There is no need to do anything with your model. You just add the Nioka library and export it as is. Looks like the model exported to this library, it's expected to be compatible with like PMML format, so as there is no Java version of Nioka library, and the idea was to use any other Java library to import that exported model. So we tried to use both libs with, and as for the Java side, we used GPMML library for our open scaling. So before the demo, in order to better understand in order to better understand the topic, I created a separate repository with a separate notebook, I mean, separate from our production task, to train simple LGBM model and a Java application to demonstrate the transferring model to PMML, importing it from the Java side and serving there. During the demo, we will look how the serving works, and we will do some metrics comparison to compare both Python and Java side of serving. And also, I will show all the ways about bottlenecks that we had during this work. So let's dive into the code. 1 second. So here is the code. I had both Python notebook here. I had both Java code here. So let's first work with Python notebook. I will show you how to train the model, how to serve it, and how to save it to PMML. So here is the documentation about open scoring. Very good. You see this doc, and also the documentation about Nioka library. It's here, and this is a GPMML that we are going to use. Very simple to use. So let's dive into the notebook. Here it is. During this part of the demo, I will also point out some bottlenecks and some issues that we might have during our training and exporting our model. So let's start. First, we use the data set that I use here is a well-known wine data set. We can use it for guessing the quality of the wine. You may find this data set in very different number of libraries, and this one is grabbed from Kaggle data sets. So here it is. We see that quality of our wine. We see that our features. Let's see what we have in the quality. It's a categorical feature. Let's see the number of samples. You see that it's imbalanced. And let's, I just missed one step. This one is actually a first fix that we might, we seen in our production. We should replace spaces in our feature names to not have spaces, because in last steps that we will have here, we might have an issue if we left spaces here. So let's move on. Let's split into target feature and data features. We'll do some oversample here and use our, this is actually another fix for our further PMML issues. We should have our target as continuous without any gaps. So here is what we have as a result. You see that here we had like spaces, so we missed number one. Here we have labeled our target features and everything works fine. So let's train our model. Here we are training our model as Scikit-learn pipeline. Currently, I don't have any preprocessing, just for showing that Scikit-learn pipeline will work. What we have trained our model. We have good results. We have about 86 accuracy results. Let's move on. It's our confusion matrix, still looks fine. Training looks fine, and our classification reports, you see that we have good precision recall for all the classes. And actually, for comparison like speed, it's better to use bigger number. In the demonstration, in the presentation, I will show you results for 1 million here and from 1 million on Java side. It just because the both Python and Java has some kind of warm up, and better results give bigger number of samples, but it still takes time. So during the demo here, I just reduced it to slower number of attempts. So here is our speed. We have about 800 milliseconds, and finally we get to the steps where we export our model. So we have 3 different ways to export our model. First one is we will export our booster, LightGBM booster, without anything else. It's internal format. Let's start with it. And let's also export our model in 2 different ways. One is in Nuances library. You see how it's easy. We just put our pipeline into the Nuances library and export this directly to PMML. So it's there. And the final step is again using open scoring library with the same pipeline. Here is a little bit more complicated than Nuances. We should wrap our pipeline into open scoring wrappers. We replaced our pipeline with PMML pipeline here. We do feed and we export our model as model number 3. But it's still easy. We see the results. We see that the accuracy is the same. And now let's see how to work with PMML on Java side. Here I created a Java application. We have 3 different params here. First one is our test data set that we export here. Here it is our test data set with our features without spaces, you see. Second params is our results data set. We will create this data set to show our results, and our model. We can send model in 2 different ways. It can be PMML file, or it can be jar file that is wrapped around our PMML model. In order to let's move with the Java side, Java code to the end. So here is a helper method to read our CSV file. Here is our help methods to save our prediction results. Here is our code to load our model. It can work in 2 different ways. One is to import PMML, convert it to a jar file, and serve it after that. And the second is to load directly jar files that can be received from here. Actually, both variants works fine. Let's move on. And finally, we have a main part of this solution. One of them. So what is happening here? We reading our data. We reading our model. We get our input fields from our model and our target field from our model. And here we processing our data set, testing data set. We process every rows from that, receives some results, some prediction for every row, and save it back to another data set. So this part of code just iterates over all our data to save our prediction. And here is another same part of code, but we do it in actual presentation. I used 1 million. Here I have only 1,000. We iterate over that amount of data, and we investigate how much time it will take to do this kind of test. One small thing about show is how we fill our data to our model. We iterate over fields that our model requires and put the values from our CSV file into that field value. Actually, this code works fine with every data type that we can have and with categorical data as well. So let's move to the iteration, to the working with our model. First, let's see what we have. We have our model is as a booster file. It's here, txt file. We have to convert it to PMML. And we have NIOCA export, and we have open scoring exported pipeline. So let's first convert this model to PMML. In order to do that, we return into this library. Here it is. And what I do? I just execute that library. You see that I execute PMML jar file with 2 inputs. One is the link to my model, and another is the output where to save my PMML model. So when the model is fine, the conversion goes smooth, and we got the result. So here is it should be here. Well, it is here. We have this model. Let's look at it. We see that we have our target feature. We have our features that our model receives. We have all our trees here. So everything looks fine. Other models like NIOCA library looks almost the same. We see that it's exported by NIOCA. As for open scoring pipeline, it should be similar to NIOCA export. And we see that it is similar. We have GPMML Scikit-learn, we have our target feature, we have all our input features, looks similar. Let's start to work with it. I created three different configurations here. Let me show it. We just execute our application with 3 different params. Same input CSV file and different results and different models. We just run it. First, we will run our first model. Let's do it. Let's start reading data set. Evaluation. And we got the results. You see that Java warm-up is different, and probably next time it will be faster. Here we just have the result that the model works. We can execute, it's actually booster, work with a booster model. Let's try NIOCA export, run it. It will be a little bit fast compilation time this time. And what we have for NIOCA is actually an issue. You see, that Nuoka libraries, unfortunately, we failed to fix this issue. We cannot correctly work with the model that exported with Nuoka library. Probably some other Java library will work with this fine, but as for PMML, it failed. But open schooling format works fine. As for this format, I guess it's an execution of Scikit-learn pipeline with LightGBM model inside. And you see that everything works fine. As for the speed, it's different because we have Java warm-up. If I execute it another time, the same. See that the result might be different. So it's better to use bigger number of attempts to investigate the model inference time more accurate. So it's time after time, it's different. So let's move to the presentation again. So to sum up what we have as a result, looks like Nuoka library does not work for us. It's very simple to use it, but looks like this format is not compatible with open coding, and probably we should use another library on the Java side to work with Nuoka export. That is pity. And for the other experiments, we can see that both type of export, like booster model and pipeline model, works fine. We can export, we can execute it, we can get some results. 1 second, we haven't completed. Let me show you some other step. Let's just make sure that everything works fine. How do we can work without that? Let's return to our notebook and verify that our model actually returns the results. That is correct. We see we ordered our prediction. Looks like our prediction are the same. We just compare that they are always the same. And we see that they are always the same. So our models on Java side and Python sides are actually returning correct results. So that is what I want to say, that our models booster and pipeline returns correct results. And as for the performance, I will show you it on the next slide. As I said, it depends on warm-up time for Python and Java platform, and I did it with a bigger number of attempts. As for pipeline itself, currently we haven't yet got any differences between exported model like booster and pipeline, but in real life, if we add some extra steps to our pipeline, the real execution time may be different. So it depends on the preprocessing functionality. As for the demo, we used a classic Vine dataset that does not have any categorical features. In our real application, we had categorical feature, and what I should say is that categorical feature works excellent in both versions of exported model, like booster, and pipeline works excellent with categorical data. The only requirement is any categorical feature should have at least 2 different values, because if it has same value for the whole data set, that categorical feature will not work. We should just get rid of it. after that, exporting and importing such PMML will work fine. So let's move to the performance comparison. Actually, you see that here I have 1 million on both Python and Java side, and I executed it on the same machine. And you see that results on Python side, we have about 800 milliseconds, and on Java side, on both booster model and pipeline model, we have almost similar results, about 100 milliseconds. So we see that the Java execution for the big amount of attempts is 8 times faster than Python side. On the real application, our production application, we have even bigger differences. It was about 15 times faster. And I should say that it also depends on certainly warm-up time, model size, batch size, type of our model. Here we have multi-class model. In our production, we have binary classifier. And it's always a good idea to verify your goal that we have good results. Here we see that we have good results. So what we already seen. We've already seen some workarounds for some issues that we might have, but here I will also highlight some other problems that we might see during our import model to PMML. So the very important bottleneck that we start in our production project, as you remember that we had binary classifier there, is categorical data. When we had single value in the data set, in that way, we just failed to import and export our model, for export our model on Java side. Second issue, again, categorical data, when we have textual data and we have some special symbols there. So possibly workaround there is to convert your textual data to have some like relabeling or some encoding functionality before you send it directly to PMML. And also, you might remember the issue from our demo that the target feature should be continuous feature from 0 to the number of values. And another issue on our production environment, you see that we had used Scikit-learn pipeline, and it supports a big amount of functionality. We can use one hot, label encoding, and so on. We can use everything, but in production we failed to use functionality that we wanted is calibration. Calibration is not implemented on PMML, and we had to get rid of it. And just for the license for OpenSCORN functionality, it currently a fair general public license. So if you want to use it in your production, you should know about that and probably contact to the owner. So let me share the sources here. You might refer to it. You might try it on your own. It's shared. You can scan it and get the repository. And as a conclusion, I should say that there is no panacea for machine learning serving functionality. Every new project brings its own requirements that drives us to use different solutions. Sometimes we should even return to solutions that we rejected for the previous project because possibly this time it works for this particular project, and even more different solutions like MLOps tools performs to evolve and starts to supporting features that they didn't support before. Also, I should also you should always remember about the limitation, but of course, different bottlenecks or different issues that you might see in particular solutions might be okay for you one project and might be an obstacle for another. So that's it. I'm done and I'm ready to answer your questions if you have anything. Studia? Yes, I do.
Oh, yeah, great. So thank you very much for such an interesting topic, and it's really pleased for us that now such a complex, things as a data science is more suitable for everyone, and everyone can get something useful from you. So if you're ready to answer questions, you're welcome.
Yeah, I already got some questions. Oh, so many questions.
Yeah, the
Okay.
topic was really interesting.
Yeah, that's great.
Well, first question, do you need to know Java well to serve model in Java application? Good question. Actually, I think that it's better to know both functionality. Well, if you, it's known belief that data scientist should not be a software developer. You should just do some kind of research and so on. And the coding is for Java developers or Python developers. I'm not on that like group. I think that data scientist is still a developer, and it's better to use to know your functionality from what you want to use. If I had some experience in Java, why not? I can do it myself. I can spend some time there. If you more like scientist, you can try to work together with the developers that will work that will serve your model. Like you might have MLOps team that you will talk to and that will help you with serving your model. It can be, but for me, it's better to work on both sides. Hope that it answers the questions. What was that the first time you have to convert your model to use it on a different platform? Does it always result in greater performance? Actually not. I used transfer my model to another platform. I said during the lecture that we tried on an NIX format, and we used it to transfer our PyTorch model, it's a neural network, PyTorch model to the format that can be imported on TensorFlow in order to serve our model with TensorFlow serving. We like TensorFlow serving. It's very good platform to serve neural networks, and as it supports TensorFlow, we had to convert our PyTorch model. So it's not the first one, not the first time that I worked with transferring. Did you consider moving your model to any platform other than Java to increase inference speed even more? C++, for example. Don't you know if there are any available libraries for them to that support? Actually, good question. Yeah, there are C++ libraries that supports same importing of PMML. If you are working with C++, you cannot export your model. You can directly use, because LightGBM is also written on C++. But for us, it was a requirement. We had an application already written in Java, and we had to use our model there. So we can definitely work with C++, but for us, we had to use that. We had to use Java. Is open scoring library free for use? Well, it's open source, and it's, let me show you one of this, let me show you this a little bit more. You see that requirement said that it's a fair public license. So possibly, if you want to use in production, you just can get in touch with the authors, and probably they will offer you BSD license for this library. So question number 5, does open scoring library have supports of models built with deep learning frameworks such as TensorFlow and PyTorch? I guess they can. I haven't remembered from my mind, but possibly yes. However, I don't think why you need to that, because if you have PyTorch or TensorFlow, there are another like TensorFlow serving or PyTorch. It also can be served and very fast, very good. Possibly yes, but you can refer back to the documentation. Possibly yes, I don't sure. Did you try to serve your model as a web service and work with it via REST? Actually, yeah, we tried that, but unfortunately, that is not always good, because it adds some additional time that needs to be spent to create a request, to send it via network, and to receive it, to parse it, and so on. So the idea of this application is to be very fast and return the answer very fast. That is why it's integrated into the functionality that works with the bits. Do you know what are the model serving options for mobile application? Do you know what are the model serving options for mobile application? Actually, I don't understand this question. Model serving option. About options. There are not so much options for PMML. As for exporting, we just specify our model, and that's it. As for documentation, we can see PMML format. It's open source, and we can investigate for any other libraries that works with that format. Possibly we will see if there are options that might work with it. As for serving model on Java side, there are documentation, but as for the options, I don't think that they have too much options for importing. As for inferencing, yeah, it depends on different model type. If we had, for instance, binary classifier or multi-class classifier, they will be exported differently. And if you are working with different model likes another gradient boosting algorithm or some kind of linear classifier or some other models, they will be definitely imported different ways, and you will work with them differently. It's under the hood. Possibly you will not have options for doing that. You will just use either another library or another code to inference that model, but as for the options, I don't think that there are much options. How do you work during the error rate alert? Well, actually, during the error rate alert, I work with patient and attentively, because there is nothing to disrupt you. You just see your work, see that your work is weighted from some other people. So error rate alert does not stop my work. So that's it. Studia, I guess I answered all the questions.
Yeah, thank you very much for your contribution to this event, and thank you very much for answering all the questions. It was really great.
Thank you. Have a good day.
Yeah.
Thank you. Bye.
Bye-bye.
Bye.
Yeah, and now I would like to remember all of you guys that you can contribute to Ukrainian victory. So by scanning a QR code that you can see right now on the screen or in the links on our website and Telegram channel, you'll be able to see information about funds that we can help for Ukrainian Army Force and Rescue Force, and together we can win this war. And we'll write back in several minutes, so stay tuned.